Hello, I'm KatieSimpson, and you're listening to the summer edition of TheCurrent. Still to come, escaping NXIVM, one of the group's top recruiters turns against the organization and its charismatic leader, Keith Raniere.
I don't want to talk to Keith. I don't trust that Keith has my best intentions anymore.
We continue our spotlight on the best CBC podcasts in a few minutes. But first, turbulence, turmoil.
We just woke up to some turbulence, and then the next second the whole plane dropped and people hit the ceiling and the seatbelt signs weren't on. We had no indication that anything was going to happen. There wasn't even a rumble in the plane, and then just dropped.
It was totally unexpected. We had injuries, and they flew for about another hour while medical physicians who were on board, ICU nurses, etc., assessed everyone and said, do we turn around or not? There's broken bones, and some individuals had facial lacerations, so they had steri strips and treated those. Other individuals, that time will tell how severe the head and neck injuries. When they flew up and hit the lady in front of me, flew right out of her seat. She said she had her seatbelt on, so it's possible that in the turbulence that released and she flew up and hit her head. I tried to grab her and hold her down. So those types of injuries, it's probably 24 to 48 hours before they know how severe some of them might be.
Passengers on board Air Canada flight AC-33 from Vancouver to Sydney, Australia, are recovering after a violent jolt in the sky. The flight was diverted to Hawaii after hitting what the crew described as clear air turbulence. The turbulence was enough to injure 37 passenger and crew members, and it's a nightmare scenario for any traveler, according to my next guest, and it's becoming more common thanks in part to climate change. Paul Williams is a professor of atmospheric science at the Department of Meteorology at the University of Reading in the United Kingdom, and that is where we've reached him. Hello.
Good morning, Katie.
Dr. Williams, from what you know so far, what does it appear happened on this plane?
Well, as you've said, the airline is saying that this is clear air turbulence. And if that's true, then it would have been completely invisible, not only to the pilots through the cockpit window, but even to the radar in the cockpit as well. And that's consistent with the passenger reports that I've read, which is that the pilot came on the radio after the turbulence encounter and basically said that in the cockpit, they had no warning that this event was about to happen. Pretty scary, especially if you're a nervous flyer, and fear of flying is actually quite a common phobia.
This is probably not going to be comforting for anyone who has a fear of flying when we hear these kinds of stories and how there is just no warning. But from what you understand, what would it have felt like if you're a passenger sitting on this plane and all of a sudden the plane encounters this clear air turbulence?
Well, we have a scale for measuring how strong the turbulence is, a little bit like the Richter scale that we use for earthquakes. So it goes from light to moderate to severe to extreme. And judging from the passenger reports, this was definitely at least severe turbulence. And the definition of severe turbulence is that it's stronger than gravity. So the plane will be moving down, dropping, tens of feet, maybe more. And it'll be taking those drops will be happening more quickly than gravity can pin you to your seat. So therefore, it follows logically that if you're not seatbelted, you'll become a catapult and you'll rise up and you potentially strike your head against the cabin ceiling. And that seems to be what's happened here.
I feel like any conversation around this issue is going to be an advertisement for everyone to remember to keep their seatbelt on at all times on a plane. Much of our audience is probably very familiar with normal turbulence. And, you notice it if you're flying through a cloud, that kind of thing. But what exactly is clear air turbulence?
Yes, it's slightly mysterious, isn't it? And especially because we can't see it. And I think we instinctively fear things we can't see. So, as you say, flying through a cloud, well, at least you can see it. You know it's there. You know you're going to expect some turbulence in the next few minutes. But this clear air turbulence is generated by instabilities, normally in the jet stream, these very rapidly moving air currents up there at 35,000 feet. Basically, if the jet stream becomes too sheared, and that's a meteorological term, basically wind shear is the the process by which the wind speed increases with altitude. If that effect is too strong, then the atmosphere just can't contain the stresses and the strains, and it becomes unstable and it breaks down. And that's basically what causes this invisible clear air turbulence.
So I know you keep describing this as something that's invisible and hard to detect. Is there research underway to try and find better ways to detect this, or why is it so difficult to see this coming?
Yeah, I mean, a key source of information that pilots have is forecasts of the turbulence, which are very much like weather forecasts, but they're specialized forecasts for the aviation sector, and this is what I work on for my research. They're pretty good, and they're getting more accurate every day, but they're not perfect. They're only about 75% accurate. So I think a key lesson from this Air Canada encounter yesterday is that we really need to redouble our efforts to improving those forecasts. But also there's technology that could help. I mentioned that clear air turbulence is invisible to the radar. Well, there's another kind of technology that's a bit similar to radar, but called LiDAR. It actually uses light instead of radio waves, and that's just the right frequency of electromagnetic wave to detect the invisible turbulence. In fact, this technology exists today. The reason it's not used is it's simply too expensive and it's too heavy. But if we see the cost come down and if it becomes miniaturized, then maybe we'll see this LiDAR technology installed in planes, and that really could confine clear air turbulence encounters to the history bins. That would be a really transformative and game-changing event if it happened.
And you say that the big challenge there, though, is it's just too heavy for the planes and it's just way too expensive, right?
Currently, the business case has been analysed, and basically it costs too much. It would cost an airline more to retrofit this technology in its fleet of planes than they would save from the avoided injuries.
Wow. Avoided injuries. Is there anything that could have been done to prevent injuries in this case? We know there were 37 people that were hurt because of this jolt.
It's difficult to say what could have been done. I've checked the forecast, the turbulence forecast for that particular latitude and longitude and time where the event happened. There was no indication in the forecast that there would be clear air turbulence there. Normally, the previous pilot who flew through that airspace would be a source of information, but turbulence can be very transient. You know, it can pop up and in a few minutes it's gone. So it really is a challenging scientific problem.
How significant can clear air turbulence be? Is it something that can, in this case, we saw people were thrown about the cabin, they were injured, but is this something that can severely damage a plane, or even in the worst, most horrific case scenario, could it take a plane down?
It has taken a plane down, but that hasn't happened for a very long time, decades. So I'm always conscious that people listening may be heading to the airport right now and maybe getting a bit worried. And I really should say something reassuring, which is that turbulence is very, very rare. Something like less than 1% of the atmosphere at 35,000 feet contains moderate turbulence. So the chance of you hitting that pocket of turbulence is very rare. And that's exactly why when it does happen, of course, it makes the news, and it's the top item in the news because we're all fascinated by it. But the rarity is something that I'm very keen to stress.
And while you say that, that less than 1% chance at certain altitudes, your research so far has found a strong link between climate change and increased turbulence. Can you explain the link?
Yes, it's a good point. So normally when someone mentions climate change, we think about how it's getting warmer here at ground level. And I know you've been talking about heat waves a few minutes ago before the news. But the climate is changing at 35,000 feet as well, and it's changing because of our CO2 emissions, and that's modifying the jet stream and just increasing those instabilities in the jet stream. And so as a consequence, we've published several scientific studies now which are predicting a major increase in severe invisible clear air turbulence, by several 100% in the next few decades. So we really need to start to take this seriously and well, what can we do? We can stop changing the climate. That might be a good idea. We could improve those clear air turbulence forecasts, or maybe we could invest in this LiDAR technology. Those are the three things I think we could and should be doing to prevent, events like the one we saw yesterday becoming 2 to 3 times more common in just a few decades' time.
So is that the big concern here, that if there isn't something, whether it's, addressing the root causes, well, there are bigger conversations around what's going on with climate change, but this is just another one of those spin-off unintended consequences that we're seeing that, people will notice if they do fly as part of their regular routine. How much could this change, or how much more often could this be happening over the next few decades, if there isn't a change?
Well, according to our predictions, we might see a doubling or a trebling of the amount of turbulence in the atmosphere. It's not just turbulence I'm concerned about, actually. There's a whole host of ways in which climate change could affect aviation. It could modify the flight routes and the journey times by changing the headwinds and the tailwinds. Coastal airports might be flooded more by sea level rise and storm surges. We might see an increase in the number of lightning strikes for planes to be struck by. And a final consequence, especially in heat waves, is that planes find it harder to take off as the air gets warmer. So we might see planes essentially unable to take off because the air is so hot unless they remove passengers or luggage or cargo from the plane. So a whole host of potential impacts there that climate change could be having, and in some cases already is having, on the aviation sector.
One of the strange parts of this conversation is, climate scientists point to air travel as a significant cause of CO2 emissions in the atmosphere. And right. When you take a look at that and juxtapose it to, along with there's a greater fear of increasing turbulence, but part of the problem could be flying itself. How does that conversation happen? Or what do people need to think about around the concern? Okay, here is a problem that is causing more challenges around climate change, but at the same time, there are greater challenges to safety in the air.
Mm-hmm. Yeah, that's a great point. And, people have called it poetic justice that planes have put out all of this CO2 and now the atmosphere is fed up and getting its revenge, maybe, would be one way to see it. Yes, aviation, of course, contributes to climate change. A few percent of our global CO2 emissions come from aviation. That's currently a lot smaller than many other sectors, but of course the other sectors are decarbonising increasingly rapidly. Aviation is somewhat struggling to do that, although I think we will see electric planes increasingly coming into use, even in just a decade or so's time for short-haul flights. So there are movements there to decarbonise the aviation sector, and of course we're all committed to that change as well.
Dr. Williams, thank you for your time today.
My pleasure. Thank you.
Paul Williams is a professor of atmospheric science in the Department of Meteorology at the University of Reading. You're listening to the summer edition of The Current on CBC Radio 1. I'm KatieSimpson.